Assalamu alaikum everyone, welcome back to our another episode of ArcGIS. Today we are going to solve different kind of geographical analysis. So here you can see we have some data for digital elevation model and fault line, water level, river and Thana boundary. So we have some questions here, one for to generate the flood map and classify flood as per the FFWC categories, and that means these categories F0, F1 and these categories. So we need to solve our first question. Okay, so let's jump on the ArcGIS. All the shape files are already added here. We just need to add one thing which is in Excel format. So this is our flood points, and if you double click this, here you can see we just need to set this. Yes, now we have to go here and then going to display XY, and here we just need to put a string to the X field and nothing to the Z field, and the W water level to the Z field, and we just need to set our coordinate system here and press it OK, and then OK. It will take some time because there are so much points here, and yes, our points are now added. So if we zoom into this, you can see that this area is not covered by this flood level point data. Okay, so we need to cover this area by a interpolation method. This is totally a new method. Now we will learn how to do interpolation in ArcGIS. There are many kind of interpolation method like IDW, kriging, spline and so on. In this case we just work with the IDW. So we will search for IDW. Now we will select the IDW. Here we need to input our flood point here. So we just drag this and input here, and our Z value is our water level here. Now we just need to put a output class name. Here we will create a folder for output, then set a name idw.tif and save it. And here we need to input a barrier polyline. We just select the fault line. Here we just need to change our environment settings. We will go to the environments and then going to the processing extent unit, and the extent is same as layer dem, and then our snap raster is dem file, and then going to the raster analysis, and similarly same as layer dem, and here we will select also the dem and then press it OK. Now we will click the OK. It will take some time, and yes, finally our IDW interpolation operation is completed, and this is our interpolated map. So now we will do another operation. We just need to minus the dem model. We will do a equation from the raster calculator. Search for raster calculator, and here is the raster calculator, and here we will just select the IDW minus dem, and we will select a name flood level.tif and then save it, and now click the OK. And yes, this is our actual map of the flood level. We just need to change the symbology of this map. So here we need to go to the properties and then going to the symbology and then going to classified. Here we will select 6 classes and then going to the classify options, and there is a break values here. We will set the break values from this image. Here you can see these data, and our first question was to generate a flood level map and classify the flood level as per the FFWC categories, and this question will be solved after putting this value in that symbology. Okay, so we will put the values here. So the first number is 0, and then the second value is 0.3, and then the third value is 0.9, and then the fourth value is 1.8, 3.6, and the last one is 10.5. Place it OK, and then here you can see this is now working. So now we will change the level from that images. The name was F0 and F1, F2, F3 and F4. We will just simply change the label there, and the first one is FF, second one is F0, third one is F1, F3 and fourth one is F4. And then I will select a color RAM for this, and I select this on and then simply make it apply, and then OK. I just unchecked everything here, and yes, this is our map. Our first question was to generate a flood level map and classify flood as per the FFWC category, and here you can see, and our map is now classified as per the FFWC flood level categories. And now we need to reclassify our project for our next operations. To reclassify this, we need to search reclass and then open reclassify here. Now we will input our flood level to the input rasters, and similarly we will classify it as per before. Okay, so our class is 6 and our values are as per before and everything similar, and then going to make it OK. And now we will select a output class name, here you can see, and we select it for reclass flood level dot tiff and OK, and now make it OK. This is our the reclass of flood level. Now we will going to the attribute tables, and here you can see we just add a single field for status, flood status, and we select the type for text and make it OK. So we will just change the values of this field, so we just need to start editing and then select the reclass flood level and then OK. And now we will just input the name as per before. Okay, so the name is FF, F0, then F1, F2, F3, F4. Okay, and then we need to stop editing, and yes, we just need to save the edits. Okay, now for our special operations, we just need to convert our raster files to vector files. So we need to search another thing, which is raster to polygon, and we select the raster to polygon features there, and we just need to select the reclass flood level here, and we will select the flood status here. Okay, and we just need to set a output class name poly flood and then save it. Sorry, this is not in TIF format, this is SF file, and then press it OK. Now our raster file is converted to vector file. Here you can see, if you going to the attribute tables, and yes, OK. So now we will just add another field and then name it area square kilometer, and we set it for double and OK. And we will add another field and set a name for area percentage, and similarly double, and then make it OK. Now we will calculate our area. To calculate the area, we need to go to the calculate geometry options, and we will select the unit for square kilometer and then OK. And yes, this is our area, and now we will calculate the percentage of area. So we just need to know the sum. So here we will go and copy the sum and then select the column and going to the field calculator, and here we will select an equation here the area square kilometer divided by the sum into 100, and then click the OK. And yes, our area and area percentage is now calculated. And our second question was to find out the flood statistics for each category. Yes, now we need to copy the whole values, select all, and then copy selected, and we will make pivot table in Microsoft Excel. Here we just need to paste it in values. Yes, okay. And now we will insert a pivot table and existing sheet, and our location is here, and then press it OK. And here we will just select the square kilometer to the values and square percentage to the values, flood status to the rows. And yes, here you can see our flood level status for each category is now showing. This is the sum of the area for each categories, and this is the percentage of the area for each categories, and the total is 100%. Okay, so our next question is to identify the extent and magnitude of flood for the each thana and generate the statistics. This is not a huge task. We just need to unselect which we are already selected. Here in this case there is no such thana data here, so there is a shape file here for the thana boundary. We just need to intersect this poly flood and the thana boundary together. So here we can see we just need to go to the geoprocessing and then going to the intersect, and we just select the poly boundary to the input features and then the thana boundary to the input features, and then we will select a name for intersect and then save it. Okay, so I just need to make it OK. Now our intersect is done. Now we will go to the attribute tables. Here I just need to update the area and the area percentage. So first thing, area, so we need to select the whole column and then going to the calculate geometry once again, and then select the square kilometer here and then make it OK. And now our area is updated. We just need to copy the sum of this area. Here you can see we are copying this and then going to update the percentage. Okay, so we will going to the field calculator once again and then just change the equations. Okay, so the equation is area square kilometer divided by the sum into 100. Okay, then make it OK. Now our area percentage is also updated, so we just need to select everything. We select all and then copy selected and then going to the Excel once again, and we will just add another field and then paste all values here and make it OK. Now we will just insert another pivot table for these operations. Okay, and this existing sheet we will select this cells here and then make it OK. Now in this case we will just add the thana name to the rows and then flood statistics to the column and the area square kilometer to the values and the area percentage also to the values, and the statistics for each categories is now showing. Here you can see the thana names and the each categories here F0 to FF. Here you can see the sum of the area and also the sum of the area percentage, and this is the grand total is 100%. And this is all about the third question. And one last question, to compose a proper A4 size map. So we have already discussed how to prepare a map in ArcGIS, so I don't need to describe this once again. And this is how we actually can do some operations for the raster data to the vector data. And that's all for today. See you in next videos. Take care.